Hi everyone, the title of our presentation is Simulation-Based Learning of Resonant Circuit Analysis using PSpice. I am Subashnee, anak perempuan Marimuthu, and my group members are Siti Hasma binti Jamali and Nur Hafiza binti Shahrum. We are from Politeknik Merlimau. For introduction, we are using simulation-based learning for resonance circuit. Why simulation? Because it provides an important method of analysis which is easily understood by students. Simulation also allows students to change parameter values and see what happens. Two circuits, Rlc connected in series and parallel, are taught, and the output is observed by the students using PSpice software before students perform the lab. This will help students to understand the frequency response curve before doing the actual lab. The reason we came up with this simulation-based learning of resonant circuit analysis is due to the problems that we observe. We found that students have difficulty in interpreting the results when they perform practical using electronic components. And students have to spend time thinking on how to plot the output resonance graph. To solve the problem, we came up with a solution to help the students to understand what are the expected results from the laboratory that they perform, and to make it easier for the students to plot the output graph. So our objective here is to build a simulation-based learning of a resonant circuit. And the circuit that we focused here is the Rlc resonant circuit connected in series and the Rlc resonance circuit connected in parallel. For methodology here, we have 3 parts: to construct, to set up, and to observe. To construct the circuit, we use the PSpice application, and for setup, the students need to set the value of R, resistor, L, inductor, C, capacitor, and the value of the voltage source, which is V sign. And the student has to do the setup and simulate the circuit. From the simulation, the student will obtain the output graph, and they can observe the frequency response curve and obtain the reading for current and frequency. This is the methodology in the form of block diagram. Students will have 2 circuits to draw, which is the Rlc series resonance circuit and the Rlc parallel resonance circuit. Both the circuits will be drawn using PSpice application. Once the student have completed drawing the circuit, they will obtain the output graph. From the graph, the students can obtain the value of the current and the value of the frequency. Let's look at the construction of the circuit. There are 2 types of circuit here: the Rlc series resonance circuit and the Rlc parallel resonance circuit. For the series resonance circuit, students have to use resistor, inductor, and capacitor and do the wiring in series. The value for resistor is 200 ohms, capacitor is 470 microhenry, and capacitor is 10 nanofarad. All these 3 electronic components are connected in series, and a voltage source is supplied to all the components. For the Rlc parallel resonance circuit, the value of resistor, inductor, and capacitor is the same, All these components are also connected to a voltage source, and both the circuits will be simulated using the setup in the PSpice application. Once the student have completed the simulation, this is the graph that they will obtain. The graph that they obtain is the graph current versus frequency. For the resonant circuit connected in series, students can obtain the value of frequency from the x-axis and the value of current from the y-axis. They can get the value by using the cursor probe in the PSpice application. When they put their cursor at the peak, the value is displayed automatically. Students can write down the value, and when they do the hands-on experiment, they can compare the value and they can see if the value is the same as the simulation. This helps them to get the value earlier. Among the impacts of this simulation-based learning of resonant circuit analysis are: students can increase the understanding of the resonance topic. It can make students prepare earlier for the hands-on of the particular topic. It also provides students with the knowledge to plot the current versus frequency graph. Students are also able to easily change the parameter values of resistor, inductor, and capacitor to observe what happens to the frequency response. This is easily done because PSpice software can produce the value immediately from the software. As for conclusion, we observed that the simulation process helps students to understand the laboratory process better. Students are able to plot the graph well, as they already know where to obtain the value of Imax and frequency response. Students are more confident with their lab, and they can complete their lab earlier. We are starting with RLC circuit connected in series. So get your components, use the part browser, type R for resistor, L for inductor, and C for capacitor. Then get your voltage source, type V, and look for V sign, and ground. Then complete the wiring. Once the wiring is done, change the value as the given lab. This is 200 ohms. This is 470 micro. And capacitor is 10 nano. Then put in the values for V1, starting with DC, which is 0 volt. AC 5 volt. V offset 0 volt. V amplitude 5 volt and frequency 100 kilohertz. Then put the value of your AC sweep. Total points 101, starting frequency 10, and your ending frequency is 200K. Then save your circuit. Okay, once you have saved, you can do the simulation. So go to trace, add trace, and get your graph. So you have current versus frequency. From here, you can get the value of the resonance, frequency, and the voltage. So go to cursor, display, and just place the cursor where you want to get the value, which is at the peak, and press here. So you can see here the value of the frequency during resonance is 74.444 kilohertz, and the current is 24.982 milliampere. After observing the graph for RLC connected in series, now let's observe for RLC connected in parallel. For this, it is the same way of getting the circuit, and the setup here for the voltage source is DC 0 volt, AC 5 volts, V offset 0 volt, V amplitude 5 volts, and frequency 100K. Once the setup is done, you can save your circuit. Go to setup. Setup is AC sweep. Total points is 101. Starting frequency is 10 and end frequency is 200 kilohertz. Continue simulating your circuit. And get the plot. Trace. Here, get the cursor and place the cursor here to get the value of the frequency and also the current during resonance, which is 22.963 kilohertz for frequency and 2.1349 for current. Thank you. We have come to the end of our presentation. Thank you very much for watching.